Okay, thank you, everyone. I want to stress first off that I'm going to apologize up front because this is so preliminary still. Our project was pretty severely disrupted by the recent events, and we haven't actually gotten to meet now for almost 6 weeks. So the results are a bit preliminary. I apologize for that, but I'm still really excited to share with you, and I really appreciate Zach's efforts in keeping this session alive. I'm going to be talking about how we're using elements of network science to assess resilience of cities, and in particular, their ability to adapt during a shock. I'll talk a little bit about the motivating questions, then the methodology, finally some preliminary results, and we'll talk future directions and conclusion. There are a number of questions that we hope to address using this research, but this is the primary one I want to talk about today. We know there are a limited number of typologies of responses that a city might have to a shock in terms of their economic structure. Some cities are permanently altered, while others slowly respond during the shock and then long after. Some rapidly adjust simply in response to the shock and then return, which might not be considered adaptation at all. And then there are those cities that don't seem to be largely affected in terms of their economic structure. The question we want to ask with this data and this analysis is, what do each of those different types of responses mean in terms of the economic performance of the city and to the economic health of the residents? So there's a question I want to answer before I get into the main methodology, which is how we best compare cities. I'm going to present a really cartoonish example of a question that we have tried to answer in previous research, and why simply using distribution type comparisons isn't very helpful, and why we sought out a network solution. In this cartoonish example, we have found what we think is an ideal labor distribution for locating, let's say, a doctor's office, or a small surgical center. And it's the, I can't tell if my mouse is showing up for you guys. This is what we would like to see for an ideal labor distribution. And then we have two cities that have a labor distribution of our key occupations, city A and city B. And if we want to understand which city might be optimally staffed to grow or to open up a small surgery center, any of these distance metrics that we use to compare distributions would give us the same answer, even though we can intuitively see that city B is lacking in what would probably be a more critical occupation than city A. The lack of surgeons is probably more severe to us than a lack of taxi drivers that bring patients to an office. So that was the shortcoming we see in using simply distributions to compare two cities. So what we decided to do instead was take those distributions, create a co-location pattern, which I think you're probably familiar with, use a metric of mutual information that we have altered slightly from the traditional metric of mutual information, and then use the pairwise values that we find from the co-location analysis as weights in a new network. And I apologize that I'm going pretty fast to get through some of this background. There is a citation here that goes into a lot of the detail on the math. But essentially, we take that co-location patterns to create this network you see on the left. The links have been removed because it's a complete network, and I don't want it to be completely obscured by links. But the proximity in this network visually is based on how interdependent two industries are. Each node here is an industry. And with those weights, then we have a weighted adjacency matrix in which we can do some really interesting things. And I also want to say that this work was inspired by some of the early work by Hidalgo and Hausman, who took distributions of product categories by country to create what they call global product space. And in the time since that paper came out, others have used similar methodologies to create network spaces of, these are activities in Chinese cities. On the upper right are skills, a skill space based on the skills that are co-located within occupations. This is from an earlier paper with my collaborators on occupation space in the lower left. And in the lower right is an industry space similar to what we're using, created just last year in a paper. And I can send these citations to anyone that are interested. So having built this backbone map of a country by extracting co-locational information from the raw data, we can then go back and place any individual city within that larger national network as a sub-network based on which industries are located in each city. So each city is essentially a vector, a list of active nodes within the national network. And each city is slightly different. And here we can visually see how they appear. These are some cities in the Canadian map. Here are two cities in the US map. So the next step in our methodology then is to determine some notion of distance between two cities, some metric of similarity or dissimilarity. And more importantly, for the question that we want to ask in this presentation is, how do we measure a distance between the same city at different points in time, so that we can start to get a sense of the structural change that a city is experiencing over time. And to do that in this study, we used a methodology that was published a few years ago that measures structural dissimilarity in complex networks. And there's the citation for you. So I'm going to move right on into the results now. Again, these are very preliminary, and I apologize that we didn't get further along than I had hoped, but I still think there's some really exciting things that we've found. These are some example trajectories then of 3 cities in the US. And let me briefly describe what you're seeing here. So that I've dropped 3 bars on here that correspond to key events in the Great Recession of 2007 to 2009. The first bar on each graph is a point just before the onset of the recession. The second bar is when, according to the federal government, the recession formally ended. And then the third one is sort of an arbitrary point in time after, when the rebound period supposedly ended, and cities had either recovered or not by that point. Now what we did was construct these trajectories then. Each point is a change in network structure between period 1 and the previous period. So this point would be how much the structure of Ogden changed between 2004 and 2003, et cetera, and then on through time for each city. We constructed these change trajectories for 938 core-based statistical areas in the US, going from 2001 through 2016. And then we clustered the results using a 2-step k-means clustering algorithm. I believe it was used in MATLAB, but it's pretty universal. And we found these 6 typologies of urban responses to the Great Recession. So qualitatively, we call these cluster 1 is a group of cities that didn't really change much until the onset of the recession, and then they changed rapidly and stopped again and seemed to be permanently altered. Cluster 3 was a group of cities that were already changing slightly. Then the recession hit, and that change stopped and reversed, and cities largely ended up back in the type of economic structure they were well before the recession. There's another group that were changing already rapidly and just plowed right on through the recession, kept changing rapidly, and then sort of stopped here after the rebound period. The largest cluster, number 5 here, were a large group of cities that just didn't seem to show much of a response at all to the recession, to the shock. A little noise, little change year to year, but otherwise not much. Cluster 4 is a group of cities that changed gradually in a sort of a controlled fashion through the recession and on out through today. And then finally, this cluster 2 was another large group of cities that was undergoing some pretty rapid change until the recession hit, and then everything just sort of stopped, and they've stayed flat ever since. Now, this is where it starts to get preliminary. We haven't gotten to advance this part of the analysis much, but what you're seeing here is superimposed on each cluster the average change in per capita GDP among the cities in that cluster. This first chart shows how much the cities in each cluster changed from 2006 to 2009. So for instance, the cities in cluster 1 dropped an average of 7.5% between 2006 and 2009 in terms of per capita GDP. So these, the ones on the top that underwent some more rapid change during the recession, clusters 1 and 6, you see have a pretty large drop in per capita GDP, while some like this cluster 4 really resisted a large drop during the shock. And second, I've added now the economic performance during what we call the rebound period from 2009 to 2012. So some of these clusters, like 1 that really dropped and were hard hit during the first part, also rebounded pretty well during the second part. Some, like cluster 6 here, just had almost no rebound at all. And so in the next figure, what I've done is just combine those two to show you the effect during the full period of 2006 to 2012, which encompasses both the official recession period and the rebound period. And so you can see there's only one cluster that came out of this recession, this economic shock, with a growth in per capita GDP. The others were all down, and some more than others. There's a severity depending on the shape of this curve that we're just now beginning to mathematically analyze. And so I had hoped by this time to have more. I apologize again, but some qualitative conclusions we can already make are that those cities that perform worst economically in response to the Great Recession also had the most rapid changes in economic structure during the shock. And so that seems to answer one of our motivating questions, which was, are those cities that, let's say, stretch like a rubber band and really change in response to the shock, do they do better because of their ability to change rapidly? And it doesn't seem that that's the case, at least with this particular shock and this particular analysis. Instead, if we jump down to the bottom, it was those cities that had very measured response and gradual change to the shock that perform best economically. And in the middle, you have those cities that either didn't change at all in response to the shock, or that stopped changing in response to the shock and then didn't change also during the shock. So those could have been grouped together probably if we'd done the clustering over a smaller time period, for instance, just during the shock, and that might be a future analysis that we do. But those cities in those two groups that just did not structurally change significantly during the shock sort of performed in the middle economically. So what we're working on now is trying to get finer resolution, because there actually is a monthly data set of industry employment patterns for the US that goes back to 1990. It's just a really messy data set, and it's hard to work with on a laptop or a desktop. So we need some high performance computing assets to work with that data. And then we're really interested in generalizing this work to other types of shocks. Economic shocks are sort of global in nature, whereas things like hurricanes, earthquakes, or labor strikes are more localized. And we want to determine if the nature of the shock has an impact on which cities perform well and which don't. And my intuition is that it does, but we need to quantify that. And then the network distance metric we used, as I said, we found a paper that matched our needs, but that doesn't mean it's the optimal mathematical formulation to use for measuring the dissimilarity between sub-networks. And so we would like to really dig into other possibilities. And then finally, there are a lot of other metrics of urban health besides GDP that we could be looking at, such as inequality and unemployment and others that are associated with social well-being. And we want to incorporate those into the future analysis as well. And so that wraps up my session. I did have some collaborators up here, all at ASU I want to thank. And the funding for this small study was provided by the Virginia Piper Trust. And please feel free to contact me anytime. Happy to discuss this and any other type of related research. So that's it. Thank you.